Hey guys, this is your review for your Unit 5 quiz on Wednesday over polynomials and what we've done with them so far. So you're using this review to check your work that you did yesterday and maybe get any clarifying pieces that you may need. Remember, if you still have questions, you can send me a message on Remind and I'll do my best to answer. So the first section takes us back to the beginning. It wants us to put the polynomials in standard form, tell us the degree and number of terms, and then we're going to name it based off of the number of terms and degrees that it has. So this first one, standard form, remember that means highest degree first. So we're going to do 4x to the 5th, then x cubed minus 5x, and then plus 8. The degree of the function is the highest exponent, which here is 5. Number of terms, there are 4 different pieces. So that makes this, because of the 5 as a degree, it's a quintic. And then to have 4 terms just makes it a polynomial. This makes it a quintic polynomial. Remember, when you classify it, it should be 2 words. It has to go with a degree and number of terms. Alright, part B. Standard form again. I see this piece has the highest exponent, so it's going to go first. So negative 9, a to the 4th, then minus 12a cubed, and then plus 2a squared. This time my highest degree is a 4. I have 3 terms this time. So that will make this a degree of 4 is called a quartic. Remember, 4, core, it rhymes. And 3 terms makes it a trinomial. Alright, our next one, C, standard form. I see a degree of 3 here, but I also see it here, so I have to combine like terms. So negative 6 plus 2 is going to give me negative 4x cubed, then plus 4x. So remember to combine like terms if you have them. My highest degree is 3. We now only have 2 terms because I combined them. So that's going to make this a cubic and then binomial. Alright, last one. Standard form. Well, I'm going to distribute this guy first. So that's going to give me 2x cubed plus 6x cubed. And then I get those are like terms, so I'm going to put those together. 2 plus 6 gives me 8. This becomes 8x cubed. Our degree is 3. I only have 1 term, so this is going to become a cubic and then monomial. Alright, next section. A degree of a term, each of these only had 1 variable to work with. If it looks like one of these, remember to add up all the exponents that goes with all your variables. So like A has 2 variables, x and y. That means I have 2 exponents. I have 5 and 3 I'm going to add together. So the degree of the whole term is 8. Alright, over here I have x, y, and z. So I should have 3 exponents. It's going to be 8. The exponent for y is 1. And then the exponent for z is 6. So the degree of this whole term is going to be 15. So just remember that when it asks you for degrees of multivariable pieces, you add them together. Alright. Write each polynomial in factored form. We're going to find the zeros and state our multiplicity of each. Alright, so remember factored form, we break it apart as low as we can. So in part A, I notice I can factor out an x squared from all these pieces. So x squared moves to the front. We are left with x squared minus 4x minus 21. I can factor this middle piece. Something that multiplies to give me negative 21 but adds to give me a negative 4. Because 21 is negative, I know it's going to be a positive and negative sign. We're going to use 7 and 3. So 3 minus 7, that's how I get the negative 4. Alright, so this is factored form right here. So to solve, so I've done that part. Now find each 0. Okay, well from this first piece, x squared, that is just x equals 0. This middle piece, x plus 3, that is x equals negative 3. And then x minus 7 is x equals 7. Remember, you take them out of the parentheses and change its sign. State the multiplicity. Remember, we look for the exponent here. The exponent tells us how often it occurs. So my x in the beginning has a squared attached to it, so it has a multiplicity of 2. Okay? Remember, we also called this a double root, so you can put either one here. My x plus 3 and x minus 7, they don't have an exponent. Technically, it's 1. So these both have a multiplicity of 1. Alright, let's do the middle one. 2x cubed minus 32x. Looks like we can factor out a 2 and an x from each of these. So when 2x comes out, we're left with x squared. Looks like minus 16. This is one of those special cases. It's a difference of squares, which means it becomes, I can do the square root of each, which is x and 4, 1 plus and 1 minus. Remember, they're conjugates of each other. That's why my middle term was missing. Alright, factored form is done. Find each 0. So again, this first piece just gives me 0. There's no adding or subtracting going on. The next piece will give me negative 4. And then the last piece gives me a positive 4. None of them have an exponent written, which means they all have an exponent of 1. So they all have a multiplicity of just 1. Alright, last one. Last one is nice because it's already in factored form. So that's good. Find each 0, okay? Well, in this first piece, remember, we're taking it and making it equal to 0 and solving for x. So we're going to have to subtract 1 and then divide by 2. So here we have x equals negative 1/2. In the middle, we're going to have x equals positive 5. And on the end, we have x equals negative 3. Alright, their multiplicities goes along with their exponents again. This first piece doesn't have 1 written, so we know it's a 1. So this will have a multiplicity of 1. My middle guy is going to have a multiplicity of 4. And the last one's going to have a multiplicity of 5. Alright? Next section. Alright, synthetic division to find the quotient. So we're going to set it up. We have to remember to always look for missing pieces. Okay? Because if we're missing something, we have to put a 0 in its place. Alright, so we always got to look for missing pieces if they exist. They might not exist. Oh, that's not how you spell that. Missing pieces. There we go. Always look for missing pieces. Alright, so here we go. Take this piece, make it equal to 0. We're going to get x equals negative 1. That's what comes up here in the corner. Highest exponent is a 3. 3, 2, 1, none. We're not missing anything. So my coefficients can just drop down. So we're going to have 1, negative 6, and 9. Drop down the 1. And then we use our basketball. We're multiplying by negative 1. So negative 1 times 1 gives me negative 1. Alright, combine these together with subtraction. We get negative 7. Negative 1 times negative 7 is positive 7. Bring these together with addition this time. We get positive 1. Multiply, we get negative 1. 9 minus 1 gives us 8. So our answer for this one, remember we started with an x cubed, which means our answer starts with an x squared. So we have x squared minus 7x plus 1. And then my remainder is 8, so we're going to add to it 8 over the x plus 1. So that's our answer for that one. Alright, next one. Alright, so this piece I'm going to have negative 3 in my corner. Highest degree is 3, so 3, 2, 1, none. Alright, nothing's missing. So coefficients are going to drop. Drop the 6 down first. Alright, we're going to multiply. Negative 3 times 6 is going to give me negative 18. Subtract to give me 10. Multiply again, now I have negative 30. Subtract to get negative 5. Multiply to get positive 15. Looks like we're going to add to get negative 6. So again, our degree dropped 1. So this is now a b squared. So 6b squared plus 10b minus 5b. Nope, just kidding. There's no b on the last one. There we go. 6b squared plus 10b minus 5. And then we're going to bring our remainder to the end. So add the remainder, which is going to be negative 6 over our divisor of b plus 3. Alright. Alright, see down here. Alright, this time we have 2r minus 1. Remember, make it equal to 0. We're going to add 1 and then divide by 2, which gives me a positive 1/2. 3, 2, 1, none. Alright, not missing anything. Coefficients are going to fall. Alright, drop the first 4. 1/2 of 4 is positive 2. Add together. 1/2 of negative 2 is negative 1. Subtract this time. 1/2 of 6 is positive 3. So this time we don't have a remainder. And our answer here is going to be 4r squared minus 2r and then plus 6. Good. Alright, last one. Alright, we're going to have negative 7 this time in the corner. Degree is 3. 3, 2, oh, we're missing the b with the power of 1, right? So when we drop our coefficients, that's b cubed. That's b squared. I don't have a b, but then there is my constant. So don't forget this 0 right here. It will mess it all up. Alright, so we multiply. Oh, that's 0, 0, 0, 0, negative 2. Alright, so how do we write this? Well, it was a b cubed. This is now a b squared. These zeros means I don't have a b, I don't have a constant, but I do have a remainder. So it's going to be b squared plus negative 2 over b plus 7. Alright, so there's just your standard synthetic division. We were able to use it for other things also to determine if something is a factor or not. If it is a factor, remember that means that we're going to get a remainder of 0. Okay, so if we get a remainder of 0, that means it is a factor. Okay, so here we go. So right here, this means x equals 4. 4 is going to go in the corner for both of these. This first one, my degree is 3. 3, 2, 1. Oh, we're missing the constant on the end. So x cubed. Here's x squared. Here's x, and I don't have a constant, so I need to put 0 in its place. Alright, so remember, if we get a 0 in this box, it's going to be a factor. Alright, so we're multiply, we get 4. Add here to get a positive 1. Multiply again. Add to get 0. 4 times 0 is 0. 0 plus 0 is 0. So because of right here, we can say yes for A. Alright, part B. 3, 2, 1, and none. Nothing is missing, so we're going to drop my coefficients as I see them. First guy gets dropped, hoping to get a 0 in that box. So we're going to multiply. Subtract this time. Oh, look at that. Our remainder is 5. So this is a no. That was not going to be a factor. So remainder of 0 means it is a factor. This guy didn't happen. Alright. We also use synthetic division for evaluating. So it wants to know the value of P of 3. That means 3 is now going to be in the corner. Okay? So we're evaluating P. So to evaluate, our answer here, our answer is the remainder. Okay? That's what we're looking for. The answer is the remainder for this one. That's how we evaluate. So, 3, 2, 1, none, we're good. 1, 1, negative 14, negative 27. Drop that first one down. Add, that gives me 12. What is that? Negative 2. Gives me negative 6. So this is negative 33. So when I plug 3 into this equation, we're going to get negative 33 as an output for it. Alright, part B. There is something missing. Look right here. 3, 2, 1, none. We're missing the X part. So make sure you put a 0 there. Alright, multiply, add, multiply, add, multiply. Let's see, what does that give me? 6, 71? No, 81. So that gives me 79. So when I plug 3 into this one, we get 79 as an output, as a result. Alright? So synthetic division is used many ways. This one, I am giving you the roots. I want you to give me the polynomial that it came from. So, the things we have to look for, okay? If any of my roots, okay, has an I or a square root, then there must be 2, okay? That means there must be a positive and negative root, okay? So we have to look for i's or square roots. My first one is 0, 0, negative 5. Don't have an I, don't have a square root, not missing anything. So we're going to put these back in their factors. So to make this x plus 0 just means x, right? And then here to bring 5, negative 5 back to x, we're going to add it. Alright, we're going to multiply. I'm going to do these two first because x times x is just x squared. Multiply that by x plus 5. I'm going to distribute. We're going to get x cubed plus 5x squared. That is my polynomial. Notice my degree is 3, and I had 3 roots to start with. That should always match up. Alright? Okay, next one. Negative 6 and 2i. Well, right here, that's one of my pieces. So 2i means I have to also have negative 2i as my root. So I have 1, 2, 3 roots. So my answer needs to have a degree of 3 in it. Alright, putting negative 6 back in the x is going to be x plus 6. Next piece becomes x minus 2i. And then the last piece becomes x plus 2i. I'm going to multiply these together first. So x plus 6 is still here. I know that when I multiply conjugates with i's, I can do a squared plus b squared. So I have x squared plus 2 squared, which is going to be 4. That's always true when the complex conjugates, when you have that I involved. Okay? Don't forget that little trick we learned. Okay? Or you could actually FOIL it out, and if you did, you would end up with x squared minus 4i squared, and remember I squared is equal to -1. So you would end up with the same thing. Now we're going to multiply these together. Alright, so multiply, I'm going to do x to x squared and x to 4. So I'm going to have x cubed plus 4x. Then 6 gets multiplied to x squared and 4. So 6x squared plus 24. I'm going to put this in standard form. So x cubed plus 6x squared plus 4x plus 24. Just like that. Alright. So I can write that down. Remember, you can always pause if you need to. Alright, here we go. Next one. 4, -1, and square root of 10, which means I also have negative square root of 10, which means we have 1, 2, 3, 4. So my degree in the end should have a degree of 4. Alright, moving 4 back to the x gives me x minus 4. And then we're going to have x plus 1. And then x minus square root 10. And then x plus square root 10. I'm going to put these pieces together to get me x squared. Look at that, -4 plus 1 will give me -3x. And then multiply the last ones. -4 times -1 is -4. Alright, these guys, they're conjugates, so again, the middle piece won't be there. X times x is x squared. Oops. Negative times a positive will give me a negative. Square root of 10 times square root of 10 is the square root of 100, which is just 10. Now we're going to multiply these. I like to use the box method when it comes to bigger pieces like this. So I'm going to put x squared and then minus 10 over here. And then x squared minus 3x minus 4. Make me a little table. Multiply this way. Alright, so I have x to the 4th. Negative 3x cubed. Negative 4x squared. Bottom row, multiply everything by -10. Negative 10x squared. 30x. And then 40. So now we're looking for like terms. Okay, so I see x squared and x squared. But I don't see anything else. So when I go to write it, we're going to have x to the 4th first. Then -3x cubed. Combine these. So -10 minus 4 is -14. And then 30x. And then 40. Look at that. It's an x to the 4th power, just like we thought. Alrighty. D. Okay, so we have a square root and we have an I. So we're missing negative square root 5 and we're missing positive 3i. So we're going to have x minus square root 5, x plus square root 5, then x plus 3i, and x minus 3i. These together will give me x squared minus 5. These together will give me x squared plus 9. And now we're going to multiply these together. So I'm going to multiply x squared to both of them to get x to the power of 4 plus 9x squared. Then down here with negative 5 minus 5x squared minus 45. Combine these middle-like terms. We're going to have x to the 4th plus 4x squared minus 45. Right, and again, we had 1, 2, 3, 4 different roots to start with, so that's why we have a degree of 4 in the end. Alright, your two favorites. You ready? Alright. Here we go. We are going to solve by listing all possible real roots first, so my p's over my q's. Right? Remember, this first piece is your q, this last piece is your p. I need factors of 18 divided by the factors of 2. What are my factors of 18? Well, we got 1 and 18. We got 2 and 9, and we have 3 and 6. So we're going to have to divide all of that by factors of 2, which is just 1 and 2. Alright, so let's start dividing. 1 divided by 1 is 1. Then we have 18. This is all of them just divided by 1. Alright, now I'm going to divide them by 2. So we're going to have 1/2. 18 over 2 is 9, which I already have. So I don't need to write that again. 2 over 2 is 1, which I already have. Okay. 9 over 2, don't have that one. 3 over 2, don't have that one. And then 6 over 2 is 3, which I do have. So there's my list. Right? Find a 0 by using a table or plugging in values from my list. So I'm going to go over here to Desmos. Okay. I'm going to plug in my function. So we have 2x. Ooh. Come on, write for me. There we go. Okay. Took it a second. Alright, so we have 2x squared. Well, not squared, cubed. Plus 7x squared. Minus 27x. And then plus 18. Alright, so looking here, I see my intercepts. There's 1, 2, 3. So we're going to pick one of them. It does not matter which one. I'm going to pick 1. What do you think? I'm going to pick... Ooh. There we go. I'm going to pick that guy right there. Alright, so I'm going to use x is equal to 1. Which means that's what I use in the corner of my synthetic division. Not missing anything. So 2, 7, negative 27, and 18. Remember, if I pick the right one, my remainder should always be 0. So let's see, multiply, add, multiply again, and add, multiply. Whoop, it's a negative this time. There we go. Subtract to give me 0. So far, so good. Now we're going to have to factor this guy, which is now 2x squared plus 9x minus 18. Factor this to find my other 2. Okay? So I'm going to do slip and slide. I'm going to drag that 2 over. Alright, this is going to give me x squared plus 9x minus 36. So we got to think what multiplies to give me negative 36. So we know one positive, one negative. Okay? And don't forget to slide that 2 back out. Alright, multiplies to give me negative 36 and adds to give me 9. So what do we want to use? 3 and 12. Is that going to work? 12 minus 3. Yep, that's going to work. Alright. So 12 minus 3 gives me 9. 12 times negative 3 is negative 36. All right. So simplify those. So we have x plus 6 and x minus 3 halves. Take them out of our parentheses, we get negative 6 and positive 3 halves. So our solutions, and remember we have to have 3 because we started off with a cubed, right? Our solutions are x equals, well, the first one we used was 1. Now we have negative 6 and 3 halves. Those are my solutions. Alright, let's do another one. I believe this is the last one. Alright, same steps. So here is my Q, here is my P. I need factors of 9 over factors of 8. So what multiplies give me 9? Well, 1 and 9, and 3 and 3. What multiplies give me 8? 1 and 8, and 4 and 2. Alright. Alright, let's make my list. So we're going to divide everything by 1 first, just because that's the easiest to do. Alright, now divide them all by 8. So we have 1 over 8. We have 9 over 8. And 3 over 8. Alright. Divide them all by 4. It'll be a long list. 1 over 4. 9 over 4. 3 over 4. Okay. Now divide them all by 2. 1/2. 9 over 2. And finally 3 over 2. Whew. That one's long. Alright, let's plug it in though and see what our graph looks like and where it's going to cross. So we're done with this one. Let's do a new one. Alright, 8x cubed plus 22x squared minus 9x and then minus 9. Okay, it's crossing 3 times. Looks like it's crossing at negative 3 and then some decimals. Let's use negative 3. Okay, so I'm going to use negative 3 for my synthetic division. Come back over here. Oh, cancel that. Alright, so we are going to use negative 3. So that goes in our box. Alright, coefficients fall down. Nothing is missing, so no zeros are needed. Alright, drop the 8. Multiply negative 24, so subtract to give me negative 2. Multiply, this time add to give me negative 3. Multiply, and we get a remainder of 0, so we're good. Now we gotta factor this piece, 8x squared minus 2x minus 3 to get my other two solutions, because remember we already have one. Okay? We already know x equals negative 3. We gotta find the other two. Alright, so looks like slip and slide again. You could also always use quadratic formula if you want to, but you do not have to. I like slip and slide, so I'm going to slip this guy to the end. So we have x squared minus 2x minus 24. Multiplies to give me negative 24, so a positive and a negative. Don't forget to slide 8 back out. Alright, that's going to be what? 6 and 4? Negative 6 plus 4. Simplify these. We have x plus 1/2 and x minus, what is that, 3 over 4. So we have x equals negative 1/2 and positive 3/4. So there are my other ones. So there are all 3 solutions. That's everything on your review. If you have questions, please send me a message. I promise you I'm just laying on my couch right now, so bother me please. I would love to do something. Alright? Hopefully I'm there tomorrow, but if not, you still have your test, okay? Or your quiz, excuse me. Still have your quiz. Make a cheat sheet. You will get to use your cheat sheet. and you will get to use your Desmos apps on the test as well. All right? Yeah. So good luck. Hopefully I see you. If not, hopefully I see you Thursday. All right, guys. Talk to you later.